Hello there, and welcome to video 6 of the trigonometry video series. This time we're using trigonometry to solve problems. When we're using trigonometry to solve problems, we'll concentrate on drawing a careful diagram. We'll then label the sides, hypotenuse, opposite and adjacent. We'll then decide whether we should base our question on the sine, cos or tan ratios, depending on the sides we're using. We'll then write the trig equation appropriate for that question. We'll then make a move solving the equation to get the letter on its own, and we'll use our calculator to finalize our question. Here's our first example. We're asked to draw a diagram from just some written information about a triangle. Now, if we have a look at each part of this information one at a time, it says here that we have triangle X, Y, Z, so they're going to be our letters in each corner of the triangle. We said there's an angle. The question asks us to use an angle of Y, which is our 90-degree angle. That's our right angle. Angle X is 41 degrees 36 minutes, and they've given us the length of one of the sides, XY, is 6.3 meters. Our final request from the question is to find the length of YZ to the nearest centimeter. So let's see how we go about that. Step one is the first thing is to draw a careful diagram. Now let's take that first bit of information, that angle Y is our 90-degree angle. So we have a 90-degree angle that we'll draw in and label it with Y and put that 90-degree right angle symbol in there. Okay, that's a good start. Now we have another angle in the triangle, angle X, which is 41 degrees 36 minutes. We can put it in either of the two angle spots there. We'll label it X and put the angle in there. And we'll probably just complete the naming of the triangle there with our Z up the top. The next bit is to process that information that XY is 6.3 meters. Now you'll notice I've turned the XY side there red just to show you where it is. So we'll put the 6.3 down there. Okay, so we've done the triangle there, processing all the bits of information. Although we've got to on our diagram, it's probably best that we put the length that we're trying to find there. That's YZ, so that's the red one there I've highlighted. And we'll just name it YZ and go from there. Okay, so we've put all the information on a triangle that on a diagram that makes sense. Step one of the actual steps of the solution is to label the sides. So we'll start with the hypotenuse. The hypotenuse is the longest side, so we'll pop that there. The opposite is on the opposite side of the triangle to our angle over there where YZ is. That'll be our opposite side. And the other one that we haven't used yet is the adjacent side by elimination. Next step is to decide whether we use sine, cos or tan. Now you'll notice in this triangle we're using the opposite and adjacent sides. They're the ones that are involved in the question here. We have the letters that we're trying to find on the opposite side, and the adjacent side has been given as 6.3 meters. So because we're using the opposite and adjacent side, let's have a look at our three trig ratios here, sine, cos and tan. We have to pick one of those ratios that involves both opposite and adjacent. Can you see which one it might be? Involving opposite and adjacent, yep, it's the tan ratio. That's the one that involves both the opposite and the adjacent sides there. So we'll select the tan ratio as the basis of the rest of our solution. So we'll write that up the top there, tan theta equals opposite over adjacent. So that's our trig equation. Now we have to fill in into our trig equation all the information and the actual numbers from the question itself. So on the left hand side we have tan theta. Now theta is a symbol we use for a missing angle, and the angle that we have been given in this question that we're using, 41 degrees 36 minutes. So he goes in where the theta is. Then we want to put the opposite item on the top. The opposite item in your diagram there is your YZ, so he'll go on top. And the adjacent position is taken up by that 6.3 that we were given. So we're just piecing it together in the tan arrangement with the details from this particular question. Alright, so step 4 is to try and get the letter on its own. Now we've got two letters here, but still. To get the letters on its own, there's a 6.3 that's dividing into the YZ. So to move that, we have to do the opposite. So we will multiply both sides by 6.3 in order to get the letters on its own there. Now the letters will be on their own because a 6.3 that's dividing and a 6.3 that's multiplying will be able to kind of cancel each other out there, leaving us with just the letters on their own. Okay, so the YZ on the right hand side is on its own. We'll just switch sides there for the ease of the rest of the solution. See, on the left hand side we have a 6.3 multiplying by a tan 41 36 there, so we'll just write that out. 6.3 times tan 41 degrees 36 minutes, and seeing we've got the letter on their own now, we'll just process that through our calculator. 6.3 times tan 41 degrees 36 minutes. Now if you're wondering how we enter 41 degrees 36 minutes, we use our degrees button in both cases. So we'll type into our calculator for that step there, 6.3 multiply button, then tan, we'll press 41, then the degrees button, then 36, then the degrees button again, and then press equals. So that's how we enter 41 degrees 36 minutes. And we've got our final answer there, 5.59 centimeters, rounded off to the nearest centimeter. So quite a process. The main thing there, other than what you've learnt before in previous videos, is to practice the skill of drawing an accurate diagram using each bit of information that we are given one bit at a time. Okay, we're talking about ladders and walls here, not just triangles, but in the end it'll boil down to a right angle triangle, I'm pretty sure, otherwise we're in a lot of trouble. Okay, a ladder leans against a wall, making an angle of 74 degrees, 25 minutes with the ground. If the ladder is 3.2 meters long, how far up the wall does the ladder reach? So let's draw a ladder and a wall. And I've put in there that the ladder is 3.2 meters long, which is in the question there. If we read the question carefully, it says a ladder leans against the wall, making an angle of 74 degrees 25 minutes with the ground. Can you see the angle that the ladder makes with the ground down there? So that's where we're going to put that angle size there. And we'll assume for the purposes of this question that it's not the Leaning Tower of Pisa wall, it's actually a vertical wall. Most walls we can count on as being vertical, I hope. Okay, so we've got that part of the diagram there, and we want to know how far up the wall does the ladder reach. I'm going to call that D for distance. I could call it H for height up the wall, but we're already using an H for hypotenuse in these triangles, so it's probably best to avoid H in our lettering there. But that's what we're after, how far up the wall does the ladder reach. So that's our diagram. We're going to label the sides now. And so the longest side of any right angle triangle is a hypotenuse. We'll put that in first. Now the opposite side is the one that's opposite the angle that we are using for that particular question, and that's over there, so we'll label that the opposite side where the D is. And the adjacent side is just the third side that we haven't done yet. We've got to decide whether this is a sine, cos or tan question here. So let's have a look. This triangle is actually using, the D is on the opposite side, and the 3.2 that we are given is on the hypotenuse side. So they're the two sides that are involved in this question. Let's have a quick reminder of all our trigonometry ratios here. Which one of these three trigonometry ratios involves opposite and hypotenuse? Okay, sine is using both opposite and hypotenuse, so we'll choose sine as the basis of our question. So we'll write that sine ratio out at the top. Now it's time for us to fill in the question, fill in the sine ratio just under here with all the numbers that are relevant to this particular question. Sine theta, the angle we're working with here, theta is for an angle. The angle we're working with here is 74 degrees, 25 minutes, so we'll call that sine 74 degrees 25. On the right hand side we want an opposite up the top and a hypotenuse down the bottom. Now the opposite is where our D is, and our hypotenuse is where our 3.2 is from our diagram. Okay, so we'll fill that in. Now we'll try and get the letter on its own. How do you move a 3.2 that is dividing? We'll multiply both sides by 3.2, aiming to get that d on its own. The 3.2 that's dividing and the 3.2 that's multiplying will cancel each other out, leaving us nicely with the d on its own. So we can write out d equaling, now the left hand side was 3.2 times sine 7425. So we'll write that out. And we'll type that into our calculator carefully, and we'll get that the distance up the wall that the ladder reaches is 3.08 meters, and we'll just check how they want us to round that off carefully. So not much different there. We'll just got ladders and walls that in the end create a right angle triangle, and we just solve our problem as if we're just finding the side of a right angle triangle that we don't know about. And interpreting the question in the last spot, best to write out a sentence answer for our final answer, because we were asked in sentence form. It's up to us to answer in sentence form, particularly in a test. Okay, this one involves not a ladder and a wall, but a children's slide. It's got a phrase here, angle of elevation. Now there was a previous video in this trigonometry series about angles of elevation and depression, so you might like to revise that if you've forgotten about that phrase, but we'll process it anyway. The angle of elevation of a child's slide is 32 degrees. If the distance between the base of the vertical ladder to get up the slide and the end of the slide is 425 centimeters, we're asked to find the length of the side. So let's carefully see if we can draw a diagram for this. Now here I've drawn a slide in red and the ground in black, and this is an angle of elevation. An angle of elevation is up from the horizontal. So this is 32 degrees up from the horizontal. So that's a start there. Now it does mention a vertical ladder, so I'm going to put that there. And because it says it's vertical, I can put a right angle symbol in the bottom left hand corner of the triangle there. So you can see that it might be ladders, it might be slides, but in the end what we're dealing with here is right angle triangles. Okay, now it also said that the distance between the base of the vertical ladder on the left hand side and the end of the slide, the bottom end of the slide there, is 425 centimeters. And we're asked to find the length of the side. I'm going to call that length D. I could have called it L, but I'll call it D for this particular case. Okay, so we've got the degrees of 32 degrees, we've got 425 centimeters, and we've got what we're trying to find out. We've called it a certain letter there. Now it's time to label our sides. Longest side is the hypotenuse, the opposite side is the opposite side, the adjacent side is the one we haven't used yet. Now we've got to decide whether it's a sine, cos or tan question depending on which sides we're using. Can you see the sides we're using here in this question? We're asked to find the hypotenuse and we've been given the adjacent side. So they're the two sides we're using, adjacent and hypotenuse. So can you see from the three trigonometry ratios that are at our disposal here, which one uses the adjacent and hypotenuse? Looks like the cosine ratio uses adjacent and hypotenuse. So we'll base our question on the cosine ratio. So that's our ratio, that's our arrangement of sides and angles here. Let's have a look, see if we can fill in all the details from this particular question now. Cos theta. Theta is a missing angle, or an angle that we're using. It's 32 degrees in this case, so the left hand side is going to be cos 32. The top of our ratio here is the adjacent. It's got 425 centimeters there, so he'll go on top. And the letter this time actually ends up on the bottom. That's a bit different. It's a special variation that we had when we're finding sides in a previous video, so you might like to remind yourself of that situation. But if you remember from that situation, from that other video, what we do here is we take those two pieces there, the letter and the cos 32, and we swap places. So we swap places there, and that's how we get our letter on its own in this particular case. So when the letter is on the bottom of a ratio, we have to swap places with the sine, cos or tan section. Now if they swap places, the letter will be on the left and the cos 32 will be underneath the 425, and we'll just be careful about processing that into our calculator. Now the bottom of any fraction divides into the top, so we could interpret this 425 over cos 32 as 425 divided by cos 32. And our final answer there is 501 centimeters to the nearest centimeter. And we were expecting a side that's longer than what we had been given, because that side was the hypotenuse. It's supposed to be longer than the other two sides. So if we've got any lengths on our slide of being less than 425, we would have done something wrong in that question. It's good to have a bit of an idea of what sort of numbers you're expecting in each of these trigonometry questions. So an interesting one, that's our special variation. When we follow the order, the special order of our trig ratios, every now and again we get a letter on the bottom. We'll swap places to get the letter on its own in those questions. So once again, we'll just answer in the form of a sentence. And we were asked the question in the form of a sentence. We'll say as our sentence, the slide is 501 centimeters long. Using trigonometry to solve problems here, we're finding the height of a cliff now when we're looking down at a whale. Okay, now we've got a vertical cliff and we're looking down at a whale. And when we say the word vertical, we can put the right angle symbol in the bottom there. So we've already got most of our triangle here. Now, they use the phrase angle of depression. Once again, if you've forgotten how that works, we could look at a previous video in the trigonometry series here. We call that blue line there the line of sight. That's what your eyes would be looking down. The line your eyes will be looking down from the top of the cliff down to the whale. And we make a horizontal across the top there to make our angle of depression. An angle of depression is an angle that comes down from the horizontal, down in here. So it was supposed to be an angle of depression of 18 degrees. So we'll draw it up there. It's a funny place for it there. And we've also got the C, which we'll consider to be horizontal as well, even though it rarely is. For the purposes of maths, we'll call it horizontal. And we want the height of the cliff, the distance from the base of the cliff out to the whale. It was said in the question is 450 meters, so we'll piece that together as well. Now we do a special thing here with the 18 degrees. That 18 degrees, because this is a horizontal line across the top of the cliff and a horizontal line across the sea, it creates an alternate angles situation here, and we know that alternate angles are equal in parallel lines, so that allows us to piece together the triangle. So that 18 degrees comes down, and it's the base angle of our triangle down here. It's kind of like the angle of elevation up from the sea. So we do that fancy move so that we've got an angle on our triangle we can work with. And the last bit of piecing together the question here is to call the height of this cliff C. Now we could have been tempted to call it H for height on the cliff. That would have made sense in one way, but we want to avoid H's, I think, because we've got an H we're going to label as the hypotenuse, and it can get a little bit confusing. So let's call the height of the cliff C for cliff there. Okay, so we'll start labeling our sides. The hypotenuse is over there, the longest side of the right angle triangle we're dealing with. The side that's opposite the angle is over there where the C is, and the adjacent side has to be the other one. Okay, which sides are we dealing with here? We've got an opposite side and an adjacent side we're working with in this question. So let's have a look at our three trig ratios. Sine, cos and tan. Which one of those three trig ratios deals with opposite and adjacent? I think we're going to choose tan this time because it deals with both opposite and adjacent. So we'll piece together the tangent ratio from this particular question. Our angle is 18 degrees, so it goes where the theta is. What's in the opposite position? That's our C. That's the thing we're trying to find out. And the adjacent is 450 meters down the bottom there. So to get the letter C on its own, we're going to times both sides by 450, and that would cancel out on the right hand side there. This is a similar process each time, so I'm hoping you're getting the hang of this. That leaves C on its own and leaves the left hand side, which will turn into the right hand side here, as 450 times tan 18. We'll type that into our calculator and we get C equaling 146 0.21 meters if we rounded that off to 2 decimal places. The question actually didn't ask us to round it off in a particular way, but we're allowed to round it off in that situation any way we like, and we just tell the marker how much we've rounded it off in brackets there. So that question was about the height of the cliff. Now, we can't just leave it as c equals 146 here. We'll interpret it as far as what it means for this particular question, and we'll make a sentence. The height of the cliff is 146.21 meters. So we can be pretty precise there if we know the angle of depression there. Just by making it into a right angle triangle, we can transfer that angle down so it's on the triangle itself, and then we're going through our processes of the steps that you see in the top right hand side. So I hope that helps. That's using trigonometry to solve problems. They're all solving problems finding sides. Our last example is going to ask us to find an angle. Not much different, but it comes from a real world problem. But once again, it'll this question I'm pretty sure will end up in a right angle triangle of some description. Okay, here we've got a ramp. It rises 2 meters for every horizontal distance of 13 meters. So for every 13 meters it goes across, the ramp goes up 2 meters. I think we can draw a diagram that should represent that quite nicely, and they want us to find the angle the ramp makes with the horizontal. Okay, so here's our ramp. Now a ramp by definition sort of goes across a certain distance and up a certain distance, and we know those distances, so we can put them on our diagram and and make a right angle triangle out of it. And that's our horizontal, and I put a theta there that represents the angle that the ramp makes with the ground, or the horizontal. Okay, so that's our diagram. It's interesting, it's a bit different because we've got two sides given to us, and we've got to try and find a missing angle, which we're going to represent by that theta symbol there. Okay, we'll just label the sides once again: hypotenuse, opposite and adjacent, and I'm hoping you're getting pretty quick at that now if you've gone through the whole of the videos and lots of practice from your textbook. Okay, now this particular triangle uses the opposite and adjacent. We've been given the opposite and adjacent lengths, which is nice. So which sine, cos or tan ratio are we using? Opposite and adjacent uses the tangent ratio. So once we've selected that, we'll base our question on tangent this time. Now this is an interesting bit. Tan theta, we don't know that yet. That's what we've got to try and find out. So we can't really replace the theta with anything yet, but we can replace the opposite with our 2 meters, and the adjacent is 13 meters. So we've got that situation. Now can you remember from finding angles, from the video on finding angles, what we have to do here that's a bit different? We have to remember to do something special when we're finding an angle, and that is to press Shift tan or Shift cos or Shift sine. So in this case we're going to press Shift tan and enter 2 over 13 in our fraction button, and then put an extra bracket. We're going to press equals. Now then we have to do an extra special thing on our calculator, and that is to press the degrees, minutes and seconds button, and that'll get us get that degree listed in the right way for us, because they did ask for this angle to be correct to the nearest degree. So we have to do a bit of rounding here. If we press Shift tan 2 over 13 equals and the degrees, minutes and seconds button on your calculator, you'll get this sort of display here. Now to round it off to the nearest degree, we have to, when we round off, check the next section and see if it rounds up any, if it's more than halfway. Now we have to remember from a previous video here that in the minutes section or the seconds section, once they're in this sort of setting here, the format of degrees, minutes and then seconds, the second and third sections here are out of 60. So what's halfway of 60? Well, 30. So 44 out of 60 is more than halfway. So what I'm telling you here is we'll round up that 8 to be 9 degrees, because 44 is 30 or more. So that's more than halfway to being 9 degrees there. So we'll round it off that way, 9 degrees. And in this particular question, that 9 degrees means something. That 9 degrees is the angle the ramp makes with the horizontal. So we'll write out a sentence to illustrate that it's just not numbers we're finding here, it's a real life solution to a problem. So I hope that helps. That's a range of trigonometry examples. The first few were finding missing sides that meant something in real life. It might be a ladder reaching up a wall, or a distance to a whale, or a height of a cliff, or something like that. In this case, it's an angle that the ramp makes with the horizontal, so it's quite satisfying to use our trigonometry skills to solve real-world problems. So in that step, we first concentrated on drawing a really careful diagram. You have to slow yourself down and do one bit at a time when you're drawing a diagram. We then labelled the sides, hypotenuse, opposite and adjacent, to see what we're dealing with. We used that to then decide whether we're using a sine, cos or tan ratio for that particular question. Then we filled in all the numbers and made a trig equation out of that. And then we got the letter on its own. Most of the time we'd multiply to get the letter on its own, but there was a situation where we did a bit of swapping and dividing instead. Then we used our calculator to finalize our answer. So those steps are pretty similar to normal finding of sides and angles, but it just means that our answer in real-world problems means something. Okay, thanks for watching that video. I know it was a long one, that one, but we got through a lot of great examples there, and I hope that'll help you when you're trying to solve some problems using trigonometry. And don't forget, I have a great website, peterblakemaths.com, for plenty of videos on all different types of mathematical concepts and methods. So I hope you enjoy that. See you next time. Bye-bye.